Okay, I'm back. I'm going to do another ChatGPT physics problem. This time it's going to be ChatGPT versus Google. So let's start with ChatGPT. I'm going to pick I have not tested this problem at all. So what happens, nobody knows. But we can try out a couple of things here. So let's go to the problem. I picked just a generic, I didn't want it too complicated of a problem, but I picked a problem. Let's see, it's right here, this one. This number 47. So maybe you can see that, maybe you can't see that. Starting from rest, a boat increases its speed to 4.12 meters per second with a constant acceleration. What is the boat's average speed? If it takes 4.77 seconds to reach the speed, how far has it traveled? Okay, I don't know if that's a great problem. Let's just type in the first part. Let's just see what happens. Okay. So I'm going to type it exactly the same way. And then when I go to Google, I'm going to type it exactly the same way. So I'm looking right here. I'm going to say, starting from rest, comma, a boat increases, that's right, its speed to 4.12 meters per second with a constant acceleration. You have to say things aloud when you type. It's like the rule. Constant acceleration. What is the boat's average speed? Question mark. Go. To find the average speed of the boat, you need to know both its initial speed, which we do, and its final speed. If the boat starts from rest, its initial speed is 0. If it accelerates to a speed of 4.12 meters per second with the constant acceleration, its final speed is 4.12. The average speed, okay. The average, that's right. The average speed is just the average because it has a constant acceleration. Okay, good. Let's do the second part. If it takes the boat 4.77 seconds, I want to say it, no, they just put S. To reach the speed, comma, how far has it traveled? To find the distance of boat, you can use the formula for the distance traveled with constant acceleration. Distance is the initial velocity times time. Oh, I don't like that. Acceleration times time squared, 1/2 AT squared. In this case, initial velocity is 0. Okay, fine. And you can solve for the acceleration. Final velocity squared. What are you doing? We know that you can use the initial, so the boat had traveled 4.2. Okay, let me just do this problem real quick. It won't take but a second, and then I'll come back because it's really, I'm having trouble comprehending. I have my paper right here. Okay, so the first part, let's just draw a picture. It's useful to draw a picture. Okay, so I have a boat. There's my boat, and there's water. And it starts with V0 equals 0 meters per second. And then it goes over here. It's a sailboat, I guess. To V2, or I guess V2. V2 was what? 4.12 meters per second. And then it took 4.77 seconds. Delta T, 4.77 seconds. Okay, so the first was V average. This is just going to be V final, V2, plus V initial over 2. So it's going to be 4.12 plus 0 over 2. That's going to be 2.06 meters per second. Is that what it got? .06. Okay, that's what it got. Okay, so now it says, well, how far did it go? I think what they wanted to say was V average is delta x over delta t. That's the definition of average velocity if it has a constant acceleration. So delta x is going to be v average delta t. So it's going to be 2.06 meters per second times 4.77 seconds. You'll notice that the units cancel in my calculator. Okay, clear. 2.06 times 4.77 equals 9.82 meters. That's not what they got. Okay, so then they were trying to do this. They were trying to say y equal, or some x equals x0 plus v0 t plus 1/2 a t squared. So they don't give us the acceleration, but they can find the acceleration. You could find the acceleration. I could say a is delta v over delta t. So it's going to be the final velocity 4.12 minus 0 over 4.77. And this gives me an acceleration of 4.12 divided by 4.77 of 0.863 meters per second squared. And then I can put it in this equation. So I'll say this is equal to 0, that's equal to 0. I know the time, so I get clear, I get 0.5 times acceleration, 0.863 times the time squared, 4.77 squared. And I get the same thing, you see. I get the same thing. Okay, so let's look at their answer one more time. There, it's. And then I'm going to do the same thing in Google. Okay, so the first part they got right. To find the distance traveled, distance is initial velocity times time plus acceleration, 1/2 at squared. Okay, that one's okay. In this case, initial velocity is 0, true. The time is 4.77, and the acceleration is unknown. You can solve for the acceleration by rearranging the acceleration is velocity squared. Why is it final velocity squared over 2 times time? So it's going to be meters squared per second squared divided by seconds. And get meters squared per second. That's not right. Plugging in the values, we get acceleration is 0.8. That was I got that acceleration. Acceleration 2. Final velocity squared, 4.12 divided by 2. Final velocity squared. Acceleration is final velocity squared over 2 times the time. That doesn't... I don't see how they got the right answer right there. Okay. Okay. Now we know the acceleration we can use in the formula. Distance is initial velocity times time plus acceleration times time squared over 2. Okay. But it got a different answer. 0 times 4.7 plus point. All right, let's do the math. I'm going to use my calculator right here. Let's just check. I don't trust it. Let's do this one right here. Okay, so if I do clear, and I'm going to do 4.12 squared divided by parentheses 2 times 4.77. See, that's wrong. I mean, I don't see how... This is like a classic problem a student makes, right? Because they get the right number, but they did it wrong. So let's just see... I think your calculation of acceleration is wrong. That one's better. And they get the right thing. Okay, so... But then how did they get 8.66 before? Okay, that's fine. But see, it does the same thing. Okay, let's check this second thing right here. I'm going to put that in my calculator. I'm going to say... let's just do it exactly as it has it. So parentheses 0.866 times 4.77. See, I think it's doing second square and it's not squaring it. Let's just 4 point. I'm not going to square it because that's what it did. Divided by 2. I get 2.06. That's just weird. Okay, let's see. Let's just see. This answer is wrong. It's just a bad calculator from what I'm seeing so far. Okay, it's just saying the same thing. Okay, I'm going to tell it the correct answer and see what it says. I'm going to be honest. Let's be honest with this. I think you're not squaring that time. Let's see if I do that. Let's see. But see if I. Okay. Clear. Let's do it the right way. 0.866. Let's see. Clear. Put it. 0.866 times 4.77 squared divided by 2. I get the right answer. Okay, if I do let's see, clear. 0.866 times 4.77 divided by 2, I get 2. See, I don't even know how it's getting that. I don't know how your calculator works. I put in the same numbers and get what would I get? 2.06 meters. It's like working with a child. I apologize for the confusion. The average speed of the boat is 2 points. See, it's stuck on. It's funny that it's stuck when using this wrong way. Okay, this is just whacked. Now, someone did mention, what if I tell it something that's wrong is right, or if I tell something it did right and I tell it it's wrong and see what if it does. Let's say it did calculate the average speed. I calculated an average speed of 44.3223 meters per second. Let's see what it does. That's obviously not right. I don't know why it doesn't scroll down. It's not. It's kind of in a loop. Let's see. Let's try one more thing. I'm gonna just do something. Can you make a graph of the position as a function of time for this boat? Let's see. If it does, Python code, okay. VPython. You know, that's really interesting. I think it knows what I like, right? Okay, I'm gonna put this code in and see what happens. And then we're going to switch to Google and then just try this out in Google. Okay, while that's doing that, I'm going to scroll up here and I need to scroll that. Okay, let's see. So VX. Okay, it's funny because it's using X is not. This is only true. This is a numerical approximation, which I like. And they did a rate of 100. That's really weird. Okay, let's just copy this. I'm going to copy it up to here because I'm going to put it in GlowScript. And then I'm going to go over to GlowScript. I have it in a different window because it's zoomed differently. And let's run that. Just how see it didn't work. Undefined is not an object evaluating F arg names. Undefined. T max Oh, so this right here, plot. This should just be that. It should be. That's weird that I got that wrong. No, still. Position plot is not a function. Position.plot. Plot pos equals. Okay, so it needs to do this. It's a let's do this. G1 plot pos equals G curve. Now let's run it. Okay, so nice. It looks like a constant acceleration. I'm pretty happy. You will notice that it gets the right answer this way. No, or does it? Yeah, I think so. I mean, it's close. It's not exact. So let's go down here and let's put print x equals x meters. And then I'm going to go up here and make it go faster, or I can just get rid of that statement because I don't really care. And let's run that. So it's about the same thing. If I make dt smaller, it should work because it's not. This statement right here. This x is. It's not. It's an approximation. But if I make that smaller, pretty much okay. So that's pretty good. Let's see. I had to fix your code. You didn't have a G curve. Also, this gives. Let's just see what it says. Okay, well now it's going to give the whole code. And it's kind of frustrating that it types so slow. I just want to get, I mean, we can all go faster than this. Okay, while it's doing that, let's go up here and switch to Google. I'm going to just copy the code, this first part. Okay. Copy. That way I don't have to type it. Let's see if it's done. Okay, that's fine. Let's go over here to Google. And I'm just going to search for that. Let me do it over here because I had that thing shifted over so that you could see the OpenAI. So here's a YouTube video. It's speed to 4.8. Let's see if that's the right. Oh, I got to watch an ad. It's okay. It's on YouTube. It looks like the same problem with different numbers. Yeah. And it looks like it's doing it correctly. Yeah. Okay, let's go over here. 4.12. Again, a different one. It's weird. Oh, wait, that was the same thing. This is the same question. Okay, so they don't give me the answer. You got to sign up for that service. Let's try the next one. It's Chegg. That's the exact same problem. Brainly.com. A lot of these are paid solutions, yeah. So, see answer. Oh, there's the answer. Starting from rest study, I'm just looking for a good one. So this says 4.82. Some say 4.82. Some say, oh, that's kind of cute. Wait, convert miles. Did it have? Was it a different question? Okay, so I think there's a lot of answers on this on Google that you can find. Let's see if this fixed it. Okay, that position. See it. Okay, it made a new thing. I think it fixed it. Okay, let's say this gives a different final answer than your previous solution. Let's see what it says. No, the answer is 9.8. The code of providing the code. If you want to find the final solution. Why is it getting the wrong answer? I think it's just like a bad calculator. I think the problem, honestly, is that it's trying to use units with the correct powers, like time squared or second squared, and it either doesn't square what should be squared or it squares the units. The final position should be 9.8 meters. Time of 4.77, distance traveled with constant acceleration. Plugging the values. Let's see if it gets it this time. The last chance. Okay, come on. So, so 0 plus 4.2 equals 9.8. I'm just going to make it happen. How is 0 plus 4.203 equal 9.8? Okay, so it's just like, I apologize for the mistake, I'm just going to redo everything. I'm not going to fix what you had. Okay, so this is not good. I'm done. I'm done with this. It's not good. I think it's good with creating some basic code, but if you just rely on ChatGPT to do your problems, you're going to be in a bad situation. It also goes back and says, no, it's 4.2. Wow. I don't know what to say. Okay. That's it. I was going to do another one, but now I don't really want to, but we'll see. So, people like the last two videos, so maybe you'll like this one. That's enough.